And I'll just stop sharing for now. All right. We're live. Great. I just noticed that Jen has a really cool like race car seat in her. Was that a steering wheel? Did I see a steering wheel too?
What? No, there's no steering wheel.
For a second, I thought you had like the cool. Have you some people have these really epic, like Forza setups with like
Oh,
all the
yeah.
pedals and the steering wheels, but no, that's not what I saw.
No. It's just the standard racing back chair. I do have one at home, but the one at my other house is a lot nicer, just because it's Lamborghini branded.
Ooh, cool. Hey,
Lamborghini.
Edmar.
Wow.
Long time.
I know. How are you guys doing?
Doing good.
I
Really
wasn't
good.
even sure if this was. I was like, is this the right plume? Right room? Because you're doing robots.
Yeah, right.
Nice.
We're actually
Does the Isaac team know?
we're on this we're doing this JetRacer project where there's this remote control car that already exists, that's already been designed by Chitoku Yato, and who's also an NVIDIAN, and it's built off of a typical RC car you can buy. It's built off of an Orin Nano, and it
Nice.
has this full-on tutorial and all the setup, so you can build this car and teach it to drive around a set racetrack
Wow,
in
man.
real life. Well,
Uh-huh.
we are going to adapt that and say, okay, we're going to do that in Isaac Sim now, and we're developing a pipeline / technology stack so that people can train robots to do things in Isaac Sim and then deploy those robots to the real world. And that's going to include the CAD part of I'm designing a new robot from scratch. So it's the full, I've got a manufacturing problem. I'm going to design a robot to solve it. I'm going to train the robot in Isaac Sim. I'm going to deploy the robot in the real world. I'm going to evaluate its performance and then loop back wherever I need to design a robot to perform a task. And we're going to lower the cost of entry for automated robotics so that our community members can start businesses. Because I think if we can get to the point where they can train robots pretty easily, and then have a flat rate to sell these robots deployments in the thousands of dollars rather than the hundreds of thousands or the millions of dollars, which is what it costs now. And I think that would be a very scalable, excellent business for our folks.
Totally, it's great. On a similar wavelength, like yesterday at live stream, we were talking with creators using Real Illusion. Jen was there with us, but the theme was basically how much people can do now with because the barrier of entry to do a lot of the stuff is so much lower than it was even a couple of years ago. So I could. So we have a couple of resources that people can go to if they're looking to work with companies, because we have been getting that kind of question on Discord specifically, like, hey, I want to get this work. How can I do it? So there's a couple of things people can do if you're taking these learnings from Eric and others and Jen and Ashley and Maddie, and you're building stuff and you've got your experience there and you want to work with companies. Number one, there are definitely companies that reach out to us as NVIDIA and say, hey, who can I work with that's an expert on A, B, or C? So the more we know about you, the more we can refer to you. So the way to do that is on the community page, which is nvidia.com/omnivores, plural. You'll see a form where you can do an insider application. That lets us know more about you. You can also check the box that you're interested in contract work, and we can refer companies to you. The other thing, you can set up a free account on CG Hero, put up all your experience, and Omniverse is on there as one of the fields, and other Python and other related specialties. So that way, companies can search for someone who works on Python or Omniverse or any one of the ecosystem, and they'll be able to.
What was that last site? Sorry.
CGHero.com. And we're actually going to have a live stream with CG Hero team. My colleague Vince Brisebois is helping set this up now. But we're going to have these folks on. It was actually formed from the folks who did Turbo Squid. So that they're very good with this area. And there's also a checkbox for if you're doing sim ready assets, which also applies to the stuff you're talking about. So anyway, super exciting stuff, but really, really excited.
I just got to jump in just real quick and say, I was talking to a landscape architect this week who who's doing photorealistic renderings for clients who's taking 45 minutes per frame.
Wow.
And I was just like,
That's a
guy,
lot of time.
you can get Omniverse for free
Yeah.
and
That's a lot of time.
do 90 frames per second
Yeah.
and
Yeah.
do a virtual walkthrough. So I think there's a lot of opportunity if you just know how to apply materials and do renderings in Omniverse.
Yeah.
That alone is a marketable skill.
Absolutely, totally.
Yeah.
Bo, we had Bo on a couple, live streams ago talking about sim-ready assets. Ashley's been covering really cool on her live streams. I'm Jen. I'm not sure if you're in those live streams with her sometimes, but that is a great skill set to have. And as companies are really looking for these digital twins, they need people who can help create and bring in these assets. So if you're a developer making an app, or if you're a creator that has the ability to kind of put these assets together, I think there's a great opportunity right now, and it seems to be getting bigger by the day. So all you early adopters out there who are learning a lot from these, these resources and these live streams, I think you have a great opportunity if you want to seize it. It's really cool to see you're doing this. So I have to go in a few minutes, but I wanted to. I did get a couple of really cool slides from my colleague Greer, who I'm trying to convince to come on a live stream soon.
I think we should. I think we should team up and.
Is she camera shy? Is that
she's
why?
a little camera shy? She has nobody should be camera shy, but I understand, it's a little bit out of her comfort zone. But we'll get her. I'm warming her up to it because I want everyone to meet her. She does such a great job. So really hats off to her. And Tim Funkhauser, who really helped a lot with making sure there's good visibility on the good work people are doing. Okay, so the first thing, speaking of people doing good work, Aaron Luck just actually has been producing this video series on OpenUSD, and the next video of this series is just out. So I'll put a link in right here in the chat. You can see the whole series there, and there's going to be more videos coming. I think there's a couple of videos on there right now. So that is really helpful to anyone who's just learning about OpenUSD, which, by the way, is the same as USD. They're just renaming it to be more clear that it is an open, open kind of system.
Well, and there's this thing, not US dollar.
Yeah, exactly. Right.
That's true. Hashtag USD. It's all US dollar.
That's true. And actually, Pixar is the one who decided to move forward with this renaming of it to OpenUSD to make super clear to everybody in the world. So Aaron Luck has that really great series. There's also a great tutorial on Deep Learning Institute, DLI website. We can post that link in a second. And then just on Monday, in collaboration with NVIDIA Studio team, we started to announce a really cool community challenge called Start to Finish, which, as the name implies, kind of you show off where you started with something and then show us where you finished with it. I'm sure people have seen this in all different areas online. So this is the OpenUSD variant. You don't have to use OpenUSD for this stuff, but we always love to really celebrate that kind of work that's using a ecosystem with different things connecting. This one image we're looking at is none other than Mr. Jay Dizzle himself, who actually works at Nike. So he's very cool creator. And we're hoping to have him on a live stream soon. But we just want people to kind of put your work up online, show where you started, where you finished, and then a tag at NVIDIA Omniverse, at NVIDIA Studio, and then use the hashtag Start to Finish so we can promote and share and tell us what apps you used and what your inspiration was. And you're going to see some really cool stuff over the coming weeks. This kind of extends up through August, so there's plenty of time. But you can dig through your old stuff too and just kind of show us how you came about doing something. That's pretty exciting. And then, speaking of exciting, a few weeks ago, we had the Marvelous Designer team on, and we talked about their awesome app for cloth and fabric and design for not only for clothing, but you can use it for any kind of material like curtains and things like that. So for interior design, really, really cool, very easy to work with. We had one of their great users on with us to show how the workflow is, so we can post a link to the live stream. But that connector is available and working great thanks to OpenUSD. So want to shout that out. And then last but definitely not least, and I think Jen, you'll be there. Eric, are you going to be at SIGGRAPH?
Yeah,
you are. Eric's going to be there. So SIGGRAPH is around.
Maddie's going to be there. Ashley's going to be there.
I'm going to be there. It's going to be a lot of fun. We actually have a calendar we're setting up now. So if you're going to be in LA for SIGGRAPH, or you happen to be in LA anyway, area anyway, you can basically hook up with us while we're there. We'll send a calendar link. So we have a couple of rooms there. We could also meet outside, get coffee, grab a drink, a beverage, have a snack together. It would be great to talk to the users out there face to face. So yeah, reach out if you're going to SIGGRAPH. And most excitingly, perhaps, is Jensen is giving a keynote there. So we'll post the link to our SIGGRAPH page where you can look at all the crazy stuff. NVIDIA has the most papers ever from any SIGGRAPH accepted this year. I think it's 20 research papers were accepted. And last year, I think it was 17. So there's going to be a lot of great information from people all over the world showing off the great research they've done. So if you're going, please let us know. And even if you're not going, the keynote will be broadcast live. We'll post a link in a second. And it would be great to see anyone who's going to be there. And if you're not going, don't worry. We plan to kind of do a roving reporter kind of thing. We'll record some segments and try to send some clips over to Discord. Maybe one of our colleagues back at HQ will be able to kind of get a live stream going while we're there, and we can call in. So we'll try to plan something really fun. And if you have anything you need us to do for you at SIGGRAPH, let us know. If you want us to talk to a partner or something and a burning question you have, happy to do that as well. All right, so that's my intro news scoop. I'll stop sharing so you guys can continue with the good stuff.
It was a good news scope. Lots of good information.
Yeah.
It was a little all over the place, but yeah, there's always so much going on. It's hard to kind of.
Yeah, there's lots of links that were thrown in chat, so please give him a look.
Yeah, there's a lot going on. Feel like it's funny because I keep feeling like things are heating up, but like things.
Oh, they are heating up. It's definitely going to be 107 my weekend, so it's going to get real hot. I know.
I just no. I mean, with this Omniverse ecosystem, I just feel like it just keeps getting better and it keeps accelerating, and I just don't know. I don't know the limits to that. You know what I mean?
It's funny, and it's a challenge, right? Because like, if there's so many different industries that could take advantage of it, I think there's kind of a bottleneck in the number of people who are really well versed in OpenUSD. So I think, like I said earlier, no joke, I think there's a really great opportunity for people to earn some good money by leveraging this, OpenUSD to doing work for companies that really need it. If you watched yesterday's live stream, actually, Ben from Alara Systems, where Jen was previously from, he gave a great overview of kind of their some of workflows he's used to kind of start to finish leveraging different apps. And he also has a great MTO, Meet the Omnivore blog, where he shows like how he used like over 6 different apps to put their stuff together. And it actually might be over 10 apps. It was really impressive. So anyway, so I think there are definitely companies that are leveraging this workflow, and I think a lot of the people watching, I think, are great candidates to also do this type of work and make some great customers.
Cool. Let's see.
Oh, Yitsu. Okay, let me see. I think I saw your question on Discord. So if you need help with licensing, we do have someone on our team that can help with licensing. I'll shoot you their email on Discord.
Yeah, so you can send a direct message to Edmar. Is that right?
Yes.
Can he send you
He can, yeah. And I think I already have a chat with
Cool.
him already. So I'll ping him now. All right, so I'm gonna go, but have a great stream today. Good luck.
Yeah. Thanks.
I'll see
We've
you guys
got good
later.
news. So stay. I mean, you got to go, but
I'll watch.
Okay. Well, basically, so in our last session, we talked. We're looking for a kind of an architecture and a technology stack, so that we can have something that connects to Omniverse that controls a virtual robot, and then we can easily to kind of develop that something, right? Then we can easily deploy that something to a robot and have it work essentially the same way on the robot that it did in Isaac Sim. So same in the real as it is in the virtual.
That's great. Digital
In
twin
Sim,
all the
right?
way. Yeah, very cool.
And yesterday, or last week, we were talking about using containers for that. And containers are super cool. They're also so hard. Like
It's
just,
hard to set up, right?
yeah, they're very hard to set up because you're basically developing each app is all the way down to the operating system. So you've got to bundle like the operating system along with the app. You have to have if you want containers to talk to each other, the only way they can talk to each other by putting files on the file system or through like network protocols. And so if you're going to do network like real-time communication, you need to have a separate server that's running, that's setting up the communication, and it gets really gnarly really quick. And so I had a meeting with Isaac team and with Jetson team this week. And I just asked them like, well, what are you guys doing? I'm just basically soaking up what I could. And in the end, I came to understand, I should have already understood this or should have known it, but I came to understand that Chitoko Yato, the way he's operating is he just deploys a Jupyter notebook to the Jetson, and he has the Jupyter environment running on the Jetson, and he just uses the Jupyter notebook to run that Jetson, which is so much easier and simpler than
That's
messing
awesome.
with containers. We might not scale to BMW size with Jupyter notebooks, but I think it's okay to crawl, walk, run, right? So we're going to crawl, we're going to get these Jupyter notebooks running. And the idea here is we're going to take Chitoku's actual Jupyter notebook that actually already works on a Jetson Nano. We're going to bring that in and we're going to see what are the absolute bare minimum changes we need to make to get that driving the robot in Isaac Sim. And this technology stack is like 2 orders of magnitude simpler than the container stack.
That's awesome.
It's going to be so much easier. And
so is this going to be like a series or like it sounds like it will be, but how many episodes these will be?
We're mid-series, Edmar.
It's in progress.
Mid-series. Yeah, we've got a CAD model of the JetRacer already modeled up. We've got that CAD model into Isaac Sim where we can drive it around with a gamepad.
Wow, that's awesome.
using Omniverse physics. And so now all we got to do is set up an app that can control that car in Isaac Sim and get that flow. So that's really the last big part of our stack is like the software part that's driving Isaac Sim that we can deploy to our real Jetson to drive the real one. So
that's awesome.
And to Zia's question, this is really an important note. He's saying, I don't think I need the Orin then. And I would actually advise against the Orin for now. I know I went with the Orin to be more scalable in the future so I could do bigger robots in the future. I think we'll get there. But the Orin is so new, we don't have we don't even have an operating system image that will run the JetRacer stuff that has Jupyter on it. And so I'm going to have to do some extra legwork to get that going. So I recommend going with the older Jetson Nano that matches the images on the JetRacer repo so that you can just use what's already there. So there we go.
All right. Well, very cool. I'm going to catch up and watch the beginning episodes too. And again, good luck. I'll be watching from behind the scenes.
Hey, thanks for coming in, Amar.
See you guys.
All right. So let's pop over to my screen and I can go ahead and share. And I've used Jupyter Notebooks that other people set up before, but I haven't done this from scratch. Jen knows a lot more about these than I do, I believe. So let's share this screen. Let's get going. This is that website that Edmar mentioned. It's a really cool kind of, if you want to get some contract work with Omniverse, this would be a great place to sign up. So like Edmar said, they already have a category. Oh yeah, 80 sign. We're channeling our Bob Ross. We're gonna do some happy little Jupyter Notebooks today. Oh yeah, here we go. But let's start off with, we're just gonna go to JetRacer. Cool. And let's see here. Let's go to, I gotta make a little change on my, put this repository called JetRacer into my repos folder. But it's really the JetRacer extension that I was writing. So I'm just going to rename that. Cool. And I'm going to go ahead and let's just clone this first, and I'll show you kind of what we've got here to work with. So pop up my terminal. PowerShell. Does Git run from PowerShell? Totally does. CD source, CD repos. And now we're just going to clone this guy. Git clone. There we go. Cool. We're cloned. And then let's open the folder. Where are you? JetRacer. Alrighty. Yeah, so check this out. So if you look at the docs, and if I go to examples, let me open this up with my reader, open preview. Yeah, so Chitoku wrote these tutorials on you get your Jetson for the first time. How do you connect to it? And it's just like a full walkthrough from I just got my Jetson Nano to I've deployed. So this road following part, it's actually his Jupyter Notebook that walks you through training it and getting it running around this track. So, but we're going to start with this basic motion one. I think this is like our hello world that just will make it'll make the JetRacer do something. So let's start by, let's open up this notebook. So we got notebooks, basic motion. And let me make sure you can see chats. Yeah, so this is the question. Can we make the wheels turn? Let's look through the notebook. Yeah, so the car dot steering is equal to 0.3. And so there's this NVIDIA race car class that is built to interact with the Jetson. And I propose we take a look at that class and we just modify it so it talks to Omniverse instead. What do you think of that, Jen?
Sounds more complex than taking the controller and turning the stick.
Yeah, like the gamepad controller?
Yeah.
Yeah, we're going to have to figure this out a little bit. So it's not going to be as easy as that, but it's going to be easier than containers.
That is true. And it's also, something that people take for granted. You have a gamepad, and right, you have to also configure that gamepad in order to do that. So basically, we're doing the in-between work then for that, right?
Yeah. Well, and that's what this JetRacer, this NVIDIA race car class, it's doing the in-between work between this command line, this is like a wrapper so that you can just send simple commands to the computer, right? It's handling all these ports and all this communication for you. We'll take a look and see how nasty it gets, but essentially, yeah, They're just taking the car and steering that wheel a little bit. And here we go. They're setting the throttle to 0. Oh, give JetRacer lots of space to move and be ready on the manual override. I've got that set up, by the way. Let me see here. I've got the JetRacer all set up now with my Orin, which, by the way, won't work with this Jupyter Notebook directly. But so we won't do that this week. This week we're just doing the virtual version. And oh, this is interesting what Papa Chuck is saying. So we can add a listener in Omniverse and modify nothing on the script. That would be really nice if we had just like a listener extension. And yeah, but one of the features of this car that's set up. Sorry, back to the big screen. There's this thing called a multiplexer. I'm mirror imaging here. I'm trying right here. And you've got the signals coming from the radio into it. And you've got the signals coming from the servo controller come into it. The servo controller is driven by the Jetson. And what a multiplexer does is there's a signal coming from the radio into the multiplexer. And what that does is it will take signals from both the Jetson and from my radio controller, but the radio controller takes precedence. And so that means once I deploy a program to this, I can have my my controller in hand. And if things get dicey, I can like hit back on the throttle or take control with this regular old remote control. So it's cool.
Now here's an interesting question. Why do they make the remote controls look like that?
I have no idea. I mean, it's kind of weird. It's got a tire for the steering. And I don't know who came up with this.
It just looks so weird to me. It's like, why is like all of like the RC like toys?
Yeah.
Like they have like just like it's just a handle, right? Like versus like game controllers, you have like you hold them with two hands. The other one's like,
well, drones and aircraft use that style. And actually on the RC channel on the RC Discord, it that some people rig up their cars with a like a drone with the other style of controller. It's a thing, which kind of makes sense to me. But man, we got a lot of stuff rolling in. Did the multiplexer come separate? It was separate. Yep, it is in the bill of materials. And yeah, I was kind of yeah, right. Yeah, just deploy. You know, if you have an expensive, you know, I don't know, it's not thousands of dollars or something, but I mean, it was not cheap for me to build this car. I didn't feel like it was cheap. And yeah, I'm with you. Just this putting a computer and letting it drive my expensive car around without any kind of override was feeling a little scary. And so once I came to understand that what this multiplexer does, I felt a lot more comfortable with all of this. And yeah. Actually, so Zia says this is because it's only 3-channel. That is not true. This controller has, I think, 6 channels. You got this steering, you've got the throttle, you've got a 3 toggle position thing. You've got this channel 3 button, and then you have two more dials. That's 5 channels that I listed. 1, 2, 3, 4. No, yeah, 1, 2, 3, 4, 5, 6. So yeah, 6 channels. NVIDIA. That's kind of a cool username.
Oh my. I know. It's also really confused. Anytime somebody talks about generative AI, because everybody says Gen AI, and I go, what? Huh? Where? Me? I'm not an AI. I'm not a bot. I swear.
That's funny.
But I don't know. If somebody wants to make a whole digital twin of myself and my coffee, go for it. I'd be totally excited to actually see that, honestly.
Ooh. Wow, he's brave. He goes straight to half throttle.
Ooh.
No
Well,
wonder he's got to override that thing. Like
but
fly.
is it capped from a 0 to 1, or is it
Yeah.
like, is it?
Yeah, the signal. All these signals are so steering is -1 to 1 from
Okay.
a signal standpoint, and the throttle is 0 to 1, and so 0.5 is half throttle. We might start with like 0.05 or something, just to see if the motor makes a noise, even if it doesn't go. Yeah. The throttle also has a gain value that can be used to control the speed response. The throttle output is computed as the output is the throttle gain times the throttle. So you can set a throttle gain factor to kind of, if you need to, I suppose. But, oh, interesting. Yeah, and so I guess the same applies to steering gain. Well, because I think if you want a certain angle of steering, a certain steering angle, I don't know what numerical value that's going to be. There's going to definitely be some tweaking there, right? But this is cool. This is exactly what we need, is using this JetRacer class to just control the car a little bit. And I like Papa Chuck's idea is if we can write an extension in Omniverse that just listens to these signals and sends them to our joint drives. If we could do that without changing the NVIDIA race car class at all, that would be so cool. Should we take a look at the NVIDIA race car class and see what that's all about?
Can we?
Should be in here. JetRacer NVIDIA racecar.py. Oh, and there's racecar.py. Let's see if we
Race
can.
car might be a parent, or like just a base class. And
Oh, yeah, and here's from race car. Should we start in race car? Let's take a look at this.
You could, yeah. So that's interesting. So it does clip the steering and the throttle to be 1 to -1 here.
Right. Okay, so that's in the validate, clip steering, and clip throttle. That's all it does, as it looks like.
Yeah. Yeah. So it's basically saying don't put a number greater than 1. And if you do, it's going to be clipped at 1. That's really smart. Actually, I think you might understand this better, but Eric, if we didn't have that clip there and we set like the throttle to like 10, how would that end up damaging or reading through the system?
I don't know. I just know that that's kind of the way. If you look at these guys, they just send signals between 0 and 1.
Mm-hmm.
Or for the throttle, and -1 to 1 for the steering. So that's a signal you're going to get from the RC controller. Now, if you send a signal of 10 to a servo, I don't think anything. Something bad might not happen, but nothing good would happen. So
would it, like, you know how like when you were in Omniverse the other day and the car just like totally like clipped through like the whole scene and it just kind of like ragdoll? Do you think that would happen in real life? If you...
really? Yeah, the car would clip through my floor.
Yeah.
No, that would not happen. Oh, heavens. And Papa Chuck is saying you can even do an omnigraph.
You should be able to. Yeah. They have some graph nodes for that.
For listening to Jupyter Notebooks?
I don't know about Jupyter Notebooks, but I know they have nodes for controlling the car.
Well, yeah, sure. But let's just take a look at NVIDIA Race Car. And my question is, we might be able to just make a listener for this, or we might want to make like an Isaac race car class, also built off a race car that just communicates with Omniverse directly. Let's take a look. Yeah, see, there's the here's an address, right? And just a second. We're getting some comments here. Oh, interesting. We got so the embedded kernel is running in the Python environment that runs Kit. Okay. I'm not sure what embedded kernel you're talking about, because the thing that I'm maybe unsure about is that when this class has to address like ports on the JetRacer or something like that, right? Like we've got these physical pins on the JetRacer, and this class is making sure that when we say when I say when I set the steering gain and the steering offset, right? The final steering value is computed using the equation. It's the steering gain times the steering offset, or times the steering, sorry, the steering gain times the steering signal that we put in plus the offset, which is like you got your trim, right? So he's just kind of imitating the RC controller.
Isn't that just the equation of a line?
Yeah. Yeah, it's just linear. It's not too bad. We can do this, right?
I look at it one way. I'm like, that's just a line.
It is just a line. Yeah, totally just a line, right? We've got that space from -1 to 1. But if 0 is making our wheels eat off, we set that offset so that our trim B so that 0 is straightforward, right? Yeah, great. So basically, we will run a notebook on the virtual car, then send the notebook to Jetson board and run on the real car. Exactly right. But we're going to start backwards because we already have a notebook that we know works on the real car. This notebook works on the real car. So we're going backwards when we're going to run this on the virtual car. And then, and we're going to do some of that because we have a few things that we know work in the real world. And we're going to get those working in the virtual world. And then we're going to tell ourselves, okay, now let's do something new in the virtual world and send that to the real world. And this is our pipeline. And it's a nice pipeline because you can go either way, right? If we have a deployed Jupyter notebook on the real car and it's doing something wrong, we can actually bring that into the real world and debug it in the Isaac worlds. We can we know what should happen, right? We know what's happening in the real world, so we can bring that into the virtual and tweak it until we can reproduce the problem. Like let's say a toy block falls in the track, the car hits it and crashes. So what we can do then is take that program, bring the real world program into the sim world, add a toy block into our world, and make sure that whatever was happening in the real world is now happening in the virtual world. So we have a reproduction of the issue, and then we can work with our code until we can avoid the obstacle, and then deploy back to the real world, and then test in the real world. So we kind of have a really nice workflow here, and we're all and in theory, I think it just seems reasonable that it's all just using Jupyter Notebooks. So, like, really, kind of a very approachable technology stack. So, anyway, I'm pumped about these notebooks. So, but let's take a look at the race car. Car.steering. Yeah. Let's take a look at NVIDIA race car. What a simple class. I'm surprised. Oh. Adafruit servo kit. That makes sense because we are. Oh, interesting. So this I2C address must be the address we need to talk to. I don't know yet. Let's take a look. Let's keep going. the steering gain, the steering offset, the steering channel, the throttle gain, and the throttle channel. Oh, here, see our throttle gain is 0.8. And that means that if we send that signal of 0.5, it gets toned down just a little bit.
Oh,
There we go.
interesting.
And the servo kit is this Adafruit class, or this Adafruit library. That sounds nice. This isn't too bad, is it? So, self-steering motor is a continuous servo. Great. And the throttle motor is interesting that they use, but I think that would work. So we're basically saying this is probably the address of the of this. So we've got this, and I don't know for sure, right? But right here on this board, I've got. Let's go back here. Okay, so we've got the car right here's our servo motor. We want to talk to it. Let's go. If we go backwards, it's getting a signal out of this multiplexer. And if you remember, the multiplexer can take signals from the radio or from the Jetson, either one. And from the radio, we're just using this typical radio receiver right here. For the Jetson, there's this Adafruit brand servo controller right here. And Adafruit also has this Python library we can use to talk to this. And it looks like all it needs, if we go back to, let's go back. It needs to know, I'm guessing that this I2C address is the address of the servo controller as a whole. And then the steering and throttle channels are just the channels on that controller. This is making sense because I did plug those into as channels 0 and 1 on the controller. Oh, I'm getting some weird graphic stuff going on. So let's take a look at our constructor. We're going to initialize. Okay, here we have a 16-channel servo controller, Adafruit servo controller, and it's at this address on the Jetson. And then we're saying, okay, here's our steering channel, and here's our throttle channel. This isn't half bad. Yeah. And then on steering and on throttle. Oh, I see. These are just properties. And then if we change those, no, that's not right. Let's go take a look at the basic motion. Car.steering is equal to 0.3. At traitlets. So I haven't used traitlets very much. Have you used traitlets?
No, I have not. I assume they're probably properties in there, so that's what what was it, car.steering?
Yeah. So this must create a property and then also define a callback for it. So that's pretty slick. But yeah, so if you ever change oh, look at this. Self.steering motor .throttle. Okay, that's just from the Adafruit class. It's just maybe a little bit confusing naming, but we're just changing that that steering value on the servo motor equals changed new. Interesting. Times steering gain. Oh, here's change right here. So change must be the new value. So that's the new value that's coming in to the callback times the steering gain plus the offset. And here it's just the new value times the throttle gain. Right. Okay. So I think the next question then is from Omniverse. do we want to try to listen into this Adafruit stuff, or do we want to create a new class that just talks to Omniverse, talks to the Omniverse joint drivers, kind of like a separate class, you know? What are your thoughts, Jen?
I'm trying to think here. So the continuous servo is the one that's on the real one, right?
Yeah, in this basically this Adafruit class, this Adafruit servo kit, it appears to be a kit, or it's a library that handles all of the communication on the Jetson for you. So you give it the address, you know, basically where is the servo controller plugged into the Jetson, and that's all you need to tell it. It's handling all the communication in all that lower level communication. And Papa Check's telling us what he thinks we should do.
Just write a bus?
Just send it to the bus and write a custom event to listen to the bus. Do you know how to do that? I don't know how to do that, Jen. Do you know how to do that?
With 105?
So could we add something here, like a line here that's just basically printing the message somewhere or posting the message to a bus?
So you would need to, you would hook up that event listener to the system, essentially.
So instead of just posting this on steering event, instead of just posting that throttle to the Adafruit class, we could also print it to a kind of a bus, like a public bus.
Yeah, I'd be curious to know first if, because we have the notebook, right? Is if it can be connected right now to the controller, right? So we know that we're getting feedback
to the controller.
Yeah, right. Isn't this what it's going to be picking up? Is the inputs from the controller?
This is for this one. You've got this other class, basic motion, that just sets the steering value.
I see.
And so basically, this code, this notebook replaces the controller. This is the controller. Yeah.
Oh, okay.
But instead of the thumbsticks, but see the controller, it's just if you look at I don't have it. If you look at the gamepad controller, you've got those steering joysticks. That's -1 to 1.
Yeah.
And the throttle triggers are 0 to 1. So it's yeah, that part's kind of similar. Oh, actually, the throttle, I'm sorry. I said it was 0 to 1 before. No, it's -1 to 1 as well, because you can drive in reverse. Totally.
I'm thinking.
Yeah, what is the steering value of 0.3? Yeah. So if 1 is steering all the way to the right or the left, I'm not sure, to be honest, then 0.3 is just about a third of the way to the right, let's say, or the left. I'm not sure which way it goes. I'm not sure which way is positive. But yeah, I think if we can just if we can right here, if we can just kind of send a message to the ether that we can retrieve, that we can optionally retrieve from Omniverse. But I also don't know if we create this servo kit, is that going to work? I might just start by launching Omniverse and IsaacSim we have that Jupyter connector that we were talking about, and see if this runs without crashing and burning with the Adafruit stuff in there. What do you think of that as a starting point?
Yeah, you could try.
And then I could yeah.
And then I sent you information if you want to either look up later on how to do event streams.
Cool. Let's just start with that. Yeah, because we were doing that for ISO, right?
Yeah, but I made a really disgusting one because we were still in 104.
Right, and to get it to run, we had to have that separate extension enabled, or else the first one would crash and burn. It'd be nice if ideally both of these would be optional, and I guess I can make it optional. I can do a check right here and check what environment we're in, and construct the right thing depending on the situation. Really, what I should do is talk to the Isaac Sim team, and I wonder what it would take to just make this class work in, I don't know.
I wonder if it's already in Omniverse. If not, then you would probably need to have to include it as a dependency to install the Python module.
Yeah. Come on. There we go. Viewport's loaded. Let's get you out of the way. And then you said there was a Jupyter Lab notebook.
There should be. If that one doesn't work, we can always use Tony's.
I'm not seeing it in the official NVIDIA ones.
Ooh. We could still use Tony's. Tony's works.
Okay.
You might have to move the whole JetRacer. Well, actually, no, we can open up the notebook from there.
Okay.
Pretty sure. Now, what it's doing when you first enable it is it's installing some of the packages for Jupyter. So it's going to take a little bit or a little while. So it's not broken or frozen. It's just installing some modules. But once the modules are installed, anytime that you re-enable it, it should be a lot faster.
Yeah. Cool. Great question from Zia, or comment. No need for ROS. Yeah, we don't need ROS. We're just talking directly to our servos. At least not at this point. And like I've said before, I'm just trying to accelerate you all as much as I can. And if we don't need to learn a new technology to get this going, then let's not learn a new technology to get this going.
That's a nice pun.
And yeah, that's right. From Janiscu is base thing first. We're gonna start by crawling. And other things I just from talking to them, to the Isaac team and to the Jetson team, we're just going to use Onshape. And I've got a commercial license of Onshape. So I looked at their license agreement. They do not allow commercial use on the free version. I'm going to switch to a commercial version for myself. And then, but I'm also going to talk to Onshape and see if they'll let us, if they're okay with you all, basically with a free account, hopping in, downloading the files for commercial use. If they're okay with that, great. We'll just stick with them completely. If not, I'll just distribute the files on GitHub or something so that you all can download them for commercial use without having a license to anything. Then you can use whatever CAD system you need. The commercial version of Onshape is $1,500 per year. The commercial, wow. Yeah, I know CAD is expensive. That's the thing. The cheapest commercial CAD really is, you can use Fusion 360 for $300 a year. But yeah, it's all kind of CAD is pricey. So, but we have the Isaac Sim importer, we have the Onshape importer that imports joints and everything, which we like. And the thought here is we're going to develop this Onshape workflow for you all, and so that you can build whatever robot you need, including the joints, import it, and then write your Jupyter notebook that talks to whatever joints you've got. So we're kind of trying to come up with a pretty flexible workflow for you all. And to be frank, I know $1,500 is a chunk of change, but if I can't get you earning enough money that you can afford that, then I'm not getting you earning enough money. Like that's, $1,500 compared to what you need to earn to make a living is, I would say, a relatively small expense, especially where if you're deploying Orins in bulk, they're $500 each, right? And that's that's the Orin Nano is more of a consumer level. If you've got a customer who needs the professional grade edge devices, they're a few $1,000s a unit. So yeah, I mean, if you're deploying Orin or like the original Jetson Nano, I mean, I think we want to have you in a few $1,000s per sale per deployment. And if you're using the more enterprise grade edge devices, you should be in the tens of thousands of dollars per deployment. So once you think of it that way, I think that paying a few $1,000s for a CAD software, it's really going to be more important than how much the CAD software costs is how does it facilitate your workflow. So there we go. And by the way, I think the way you all might want to structure this is some of you might be more interested in designing the robots, and some of you might be more interested in training the robots. And I think that could be one of you can start a company just designing and manufacturing robots that can do various tasks that are kind of flexible, and others of you might specialize in training and deploying those robots, right? I think there's definitely space for kind of what you want to do. And if you're training and deploying, then you wouldn't even probably need CAD software. You could just talk to, Zia. Let's say you're more interested in the design part. You could actually just share USD files, like a functional Isaac Sim template with your customers, so that they can easily just train your robot. And then they don't want to manufacture it; they would just want to train it, and then buy however many units from you that they need. All right, is this going yet? It is.
Yep.
Got 3 minutes. Now what? Where is it?
So you want to go to Window, and then you do Embedded Jupyter Notebook. And what this does is it basically spins up the server. So from there, you want to go to one of those links in a browser.
Can I copy? No. Okay. Either one?
Either one.
7.0.0.1 8.2.5/lab.
All right, so now we have just a nice little web version here. So what we can do is we can actually go to a different folder, right? So yeah, you can either open it from Path or whatnot. Right now, we're just kind of pointed to this interesting.
It's all right.
Sometimes I get confused with the web version.
Oh, so path relative to JLab root.
If you cancel there, I think you can do there. Is there a plus icon next to that folder? I can't remember if that creates the folder or
this plus icon. It creates a notebook.
No, the folder plus. That just creates a new folder. Okay.
How do we find out what the Jupyter root?
Oh, where that is?
Oh, there it is.
It's right there.
Okay. Oh dear. All right, let's try this again. So we got to go up like.
If you open the extension itself, like the folder location of the extension.
Okay.
I could probably tell you where it lives.
Window, extensions, Jupyter. There we go. That's my app data local. If we open this Jupyter notebook, it's saying this root folder is, oh yeah, okay, users E Bowman, app data local.
Mm-hmm.
And I just want to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. File open from path. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then source, repos, JetRacer, basic motion.ipynb. Dang it. Oh, I should have copied it first. Let's try again.
What
File.
does open from URL do?
I can give it a web URL.
Oh, gross.
Open from path. Oh, from Jupyter groups. I bet it's is that how you do it? 2 dots in a forward slash.
Yeah.
Yeah.
Should be.
Right. Let's try JetRacer. Oh, I didn't do notebooks. Copy it. All right. This is tough.
You could also just drag the whole JetRacer project into this folder location too.
That's a good idea. Just copy it for now. Let's just do that for now. And I like that idea. Doing that over on the side. Oops. Is it just a second here. I'm lost. It's data notebooks. Right there. So that's where we're at. Cool. I already navigated to there, my window to the side. Now I'm doing this part. JetRacer. And I want to actually copy the whole folder over. That's quick. Can I refresh? There we go. JetRacer. Oh, I need notebooks too. Okay, that's fine. Cool. We're open. So now here's the grand cliffhanger moment of truth because we're out of time. Let's run this one.
So right now it's when you're running any cell, it should spit out a line. So when you, if you go in and hit play, So it'll ask you to do an embedded, which you just select because we do want the Omniverse one.
So yes, we want that. Okay.
Yeah.
So run it again.
Yeah.
No module named JetRacer.
Oh, probably because it's trying to like look for that file. So if that file's not in there, it's not gonna.
Right. So from JetRacer.NVIDIA race car. Oh, but it should. I mean, we're here in notebooks. It can't. How would we modify this a little bit? Or can it see stuff to the side?
So
Maybe-
that's in notebooks, right? So
Let's just move some files around. That's easy enough. I'm just gonna do this. Let me just grab a. Just trying to get it going right now, right? There we go. Let's just refresh here. Moved them over. We've got race.
so you can
Now we
probably
should be able to delete this, right?
yeah, exactly.
We're just hacking a bit, trying to get this.
So you probably want to keep the dot.
Oh, right. Okay. Well, it's not working. Cliffhanger.
Cliffhanger.
So we're going to keep working on this because I think this is a great way to move forward. And I think that we'll try to, I think what Papacek said about trying to add a listener to this NVIDIA race car class so that we can just listen to it as is and deploy it as is. I think that's a great idea. So we'll look into that. And so until next week, start checking out Jupyter Notebooks, start checking out Onshape, and yeah, we'll see you next week. Bye. I never know how to end these things. It's like on Talladega Nights where he's like, I don't know what to do with my hands. Seen that?
Yeah. I mean, you can always just say goodbye and then just leave and just cut black, you know?
All right. Sounds good. Goodbye.